morning, Mindsetters. This is Sibonganjalo Siposiso Bueta. Welcome to Winter School Learn Extra. I'm quite excited to be here. I hope you guys are also excited. Before we go anywhere, Mindset would like to send a quick get well message to Mandela and the Mandela family. We wish you to get well very soon, and then we thank you for everything you've done. We want you to get well. And moving on, Mindsetters, I'm here in studio with Natasha doing mathematics. Natasha, what are we doing today?
All right, Bonga, nice to see you. Nice new presenter early in the morning. Guys, I hope you are all awake. You are in the middle of holiday, so you should be awake. No excuse to be lying in bed. Today in maths, we're going to look at paper 2 work once again. This is from February 2013, so the supplementary exam from the beginning of the year. And we're going to look at coordinate geometry or analytical geometry, whatever it is you like to call it. All right, so shall we get started, Bonga?
Oh, Natasha, before we get started, Mindsetters need to know where to go to get all the information necessary. We're quite excited. It's going to be a packed show. I hope you're ready and you're willing to learn, Mindsetters. To go on our Facebook page, you go to www.facebook.com/learnextra, and then on Twitter we add Learn Extra. And then Mindset, we have a fantastic competition running up. It's called Stop the Clock. Looney will upload more questions later on on the website for more information. So keep tuned. Natasha, over to you.
All right, guys, so let's get started with our first question. We're looking at a question that's been adapted from the February 2013 supplementary exam. And remember, we're looking at analytical geometry. So in this question, we are given a diagram, and we are told that ABCD is a trapezium. Okay, now this kind of information, remember, you're not told, okay, you have to know what a trapezium is. Obviously, you learn the definitions and properties of a trapezium in grade 10, and we don't explicitly say to you guys, you know, this is what a trapezium is in an exam. So you need to remember the definitions and the properties of a trapezium. So things like, what are the properties of a rectangle, rhombus, square, trapezium, all of that, that's memory that we assume that you know because you have done it before. Now guys, just to remind you, a trapezium, remember it is, okay, let's have a look at our diagram. If we look at ABCD, in a trapezium we only have one pair of opposite sides parallel. That's very, very important with the trapezium. That's what we'll be looking at and using mainly for this question, but there's lots of other properties that you will need to know. So AD is parallel to BC. If it's a trapezium, only those two sides will be parallel to each other. Okay. They then give you the coordinates of all the points, and they tell you BC intersects the x-axis at F, and they tell you that angle DCB, which is marked on this diagram, that angle there, is alpha. Okay, let's get straight into it. First question, calculate the gradient of AD. Remember gradients, you should know that formula really, really well by now. So we're looking at the gradient of AD, and we use the formula y2 minus y1 all over x2 minus x1. Okay, so let's just look at our diagram and look at the coordinates of A and then the coordinates of D. So A is 1 and 7. That's that point there. And then D is minus 4, minus 3. Okay, so we've got A is 1 and 7, and D is minus 4, minus 3. So straightforward application of the gradient formula. We're going to say 7 minus 3. So it's y2 minus y1 all over x2 minus x1. So we get 10 over 5, which gives us 2. So therefore the gradient of AD, right? So we're looking at this line AD. That gradient is 2. Now guys, before we even go on to the rest of the questions, we can already tell, because remember AD is parallel to BC. So before we even know what the rest of the questions are, we can put down that the gradient of this line, CB, is also going to be 2. And you see, we might need that as we go on into the question. So the gradient of BC is also 2. And the reason for that is that AD is parallel to BC. And remember, parallel lines have equal gradients. Okay, and that helps us to determine the equation of BC, because remember, when you're working out the equation of the straight line, you need the gradient and the y-intercept. So the gradient we've already seen is 2, okay, since it is equal to the gradient of AD. So we've got M, we just need to find C. Okay, we look at the diagram and we see that we have, I'll go back to the diagram now, but we see that we have a point on the line that we can use to work out the y-intercept. Okay, so we've just got the gradient of BC is 2, since we have parallel lines, and I'm going to use this formula y minus, or this expression y minus y1 is equal to m times x minus x1 to work out the equation of BC. Now remember, in order to use that, we need one point on the line. We don't know the coordinates of B, but we do know the coordinates of C are -2 and -8. So that's what we will use to work out the equation of BC. All right, so we've got C is -2 -8, and that will be our y1 and x1. So we're going to get y minus -8 is equal to the gradient, which remember is 2, times x minus -2. All right, so we get y plus 8 is equal to 2 into x plus 2. All right, and we can simplify that. So I'm timesing the 2 into the bracket, so I'll get 2x plus 4. Bring the 8 over to the right-hand side, so it becomes -8, and we get y is equal to 2x minus 4 is the equation of BC. All right, so far so good. This should be easy marks for all of you in any June or final exam or prelim or whatever the case is by now. Straightforward application of the knowledge that you already have. Okay, next one, determine the coordinates of point F. So now if you look at F, okay, it's that point there, and you see that it's the point that cuts the x-axis. Now remember, a point that cuts the x-axis is called your x-intercept. So the point of the line on the line that cuts the x-axis will obviously give us the x-intercept. So to find point F, all I need to do is to find the x-intercept of the line y is equal to 2x minus 4. So this is 1.3, and we're working out the coordinates of F, which we know is the x-intercept. So we say let y equal to 0. So we'll get 2x minus 4 is equal to 0. Therefore, 2x is equal to 4. And therefore, x is equal to 2. And guys, you should always write, if they want you to find a point, write it as a set of coordinates. So you'll say x is 2, y is 0. Okay, it shows that you understand the question. You understand that if we're asking you for coordinates, we want a point, an ordered pair. Okay, so yes, you can leave it as x is 2, but they've asked you for the coordinates of F, so write it down as an ordered pair, so the x value and the y value. All right, let's go on to the next one. So still the same question. This is now number 1.4. All right. They now tell you that A, B prime, okay, notice it's no longer the original diagram, something's happened to the B. A, B prime, C, D is a parallelogram, okay, with B prime on BC. So what they're saying is you've got this other point, so there's B there. Remember, that was one of the vertices of our trapezium. Now we've moved that point B to this point B prime. Okay. And what's going to happen to the new shape is that this new shape from A to B, C, D is going to become a parallelogram. Okay, a palm for short. Okay, so that shape there, A, B prime, C, D is now a palm. Okay. They then say to you, determine the coordinates of B prime using a transformation that takes you from the point x, y to obviously send A to B prime. So they want to know, how are you going to get from this point A to that point B? What transformation gets you from there to there? Okay, we obviously can't use the coordinates of A to work it out because we don't know what the value at B prime is, okay? So we've got to look at, remember, it's a parallelogram. So in a parallelogram, all four sides are parallel, opposite sides are parallel to each other. Okay, so that means they're equidistant. So the distance from A to B is going to be the same as the distance from C to D. So what I'm getting at is if we can work out the transformation that will move D to C, we can then use the same transformation to get us from A to B. Okay, so let's see what happens. To get from this D coordinate of -4 to the C x coordinate of -2, what did we have to do? So we're looking at the x value at D being -4 and then the x value at C being -2. To get from -4 to -2, I had to add 2 units. Okay, so the transformation on the x coordinate is x plus 2. All right, then similarly we look at the y coordinate at D. All right, so that now is -3, and that's going to we're trying to get it to see what happens, or how do we get it to -8, which is the y coordinate at point C. So if I'm going from -3 to -8, what do I do to the y value? We subtract 5, so we move 5 units vertically. So the transformation on y is y minus 5, the transformation on x is x plus 2. So therefore, we know the rule that is going to take us from xy to the next point is going to be x plus 2 y minus 5. Okay. All right. So that will give us, that's what we're going to use to give us the coordinates of B prime, because now we know that A is 1. So if I want to get to the x coordinates of B, what do? I add 2. So 1 plus 2 is going to give me 3. And then to get from 7 to the y coordinates at B, we had to minus 5. So 7 minus 5 will give me 2. So therefore, the coordinates of B prime that will work to make this a palm are 3 and 2. Okay, hopefully you're all still with me. Bonga, I'm just going to quickly see if there's any questions on the 4 questions we've done so far.
Well, Natasha, for now, the mindsetters seem to be understanding everything, so no questions so far.
All right. Okay, great, guys. I'm glad you're all following. Let's move on to the next part of this question. It's quite a long one, as you can see. Okay, so it's still the same question, still the same diagram. We've got a few other bits of information that I'm now going to fill in on this new drawing. So we've got f is 2 and 0. What else have we worked out? Yeah, that's about all we'll need. They say show that alpha is 48,37. Okay, so alpha, if you look, guys, it's this angle, right, between the 2 lines. Okay, there we go. It's that angle there between the lines CD and CF. Okay, so that's the angle we're looking for. That's alpha. Right? Now, there's a whole lot of different ways and different approaches that you guys can use to get this angle alpha. You can use distances and you can do all sorts of things, but what I'm going to do is I'm going to use the method that you should all be very familiar now which is called angle of inclination. Now remember, whenever we're looking at the angle of inclination, we're always finding the angle that the line makes in the positive direction of the x-axis. So let me show you what I mean. Okay, so I'm going to extend this line CF. Oh, there we go. So that it crosses. Okay, so you can see it quite clearly. Okay, so it's just join it up to point B. And then similarly on this side, I'm going to take CD so that it cuts the x-axis. Because remember, whenever we're working with angles of inclination, we're interested in the angle that it makes in the direction of the positive x-axis. So quite a mouthful. Okay, so that means I want to get to alpha. I can't get to it immediately because it's sort of sandwiched between two lines. But what I can do is I can use this line BC to work out this angle theta. I'm going to call it theta, which is the angle that BC makes with the x-axis. And I can use the gradient of line CD to work out that angle. You can see in the direction of the positive x-axis. So in other words, we're measuring clockwise, right? And I'm going to call this one beta. Okay. If you then work out theta and beta, look what's going to happen now. Remember, this little alpha here is between the two lines. So I'm going to get, there's lots of different ways, as I say, to do it, but if I've got beta, I can work out this little angle here, right, which is adjacent to beta, angles on a straight line. And then I could use this little angle here, 180 minus theta, right? And I could then say, well, that's the exterior angle of triangle DCF, okay? So the exterior angle, remember, is equal to the sum of the interior opposites. So it's going to be equal to that one plus that one, okay? And so once we've got this little 180 minus theta, we can just use exterior angles to get to alpha. Okay, there's lots of other ways you can do it. You could find any interior angles of triangles and so on. Okay, so let's get started. First thing we need to do is we need the gradient of BC, and luckily we already have it. We know that the gradient of BC is equal to 2. We've worked it out before. Remember, when we're looking for angles of inclination, we say tan of theta is equal to the gradient. And guys, remember the reason for this, I'm sure you all know this by now, but the gradient is the change in y over the change in x. And then by definition, tan is also y over x. So therefore, we can equate them and say the gradient is equal to tan of theta, and that will help us to find theta. All right, so I've got tan of theta, so this is basic trig equations, is equal to 2. I need to work out theta, so I get my calculator up, and we're going to say, we're looking for an angle, so we need to start with shift, tan of your ratio, which is 2, and that gives me 63,43. Okay, so 63,43 is the value of theta. All right. Now we're going to do the same thing for line CD and work out this angle beta. Now, as you can see, guys, from the diagram, you can see that beta is going to be an obtuse angle. It's greater than 90 degrees. Okay, so remember also, because this is an angle that's formed in the second quadrant, that tan of theta or tan of beta is going to be negative in the second quadrant, just from your trig ratios. So therefore, when you get your angle beta, or the one that's going to be next to it, you've got to say 180 minus that to get the angle we're interested in. Let me show you what I mean. Okay, so we're going to work out the gradient of CD. All right, but apparently we're going to have to do that after the break. We've got just a few more seconds left on this question. Should we go to a break or should we finish it?
Let's finish it.
I think let's finish it because we've literally got a minute left on this question. So guys, let's finish the question before we go to a break. Okay, so let's go through it quickly. So I need the gradient of DC. All right, so we're going to use gradient formula. So it's going to be minus 3 minus 8 all over minus 4 minus 2. All right, so it's minus 3. So here we go. It's the y coordinate there, minus 8, and then minus 4 minus 2. So that's going to give me 8 minus 3, which is 5, over negative 4 plus 2, which is negative 2. So therefore, my gradient is minus 5 over 2. Okay, so I'm going to now say, well, tan of beta is equal to the gradient, which is negative 5 over 2. Okay, now when we work out beta, guys, what we're going to do is, remember, the negative just tells you which quadrant. So I'm going to say shift tan of 5 over 2. Okay, and I get 68, 2. All right. So beta is 68, 2. But look where that is. Okay. This is not your angle that's 68, 2. It's this one here, hey? Remember, so therefore this one is 68, 2. But if I want beta, which is the one right next to it, I've got to say 180 minus, because remember tan is negative in that quadrant. So beta is actually going to be 180 minus 68, 2. Okay, so it's 180 minus that, which is 111, 8. All right, once we've got beta, okay, so we know what this one is, 111, 8. Okay, we can then say, okay, lots of different ways, guys. So what I'm going to do, probably the easiest way is to work out that this is vertically opposite. So this angle here is going to be 68, 2, right? And then remember, we've worked out that theta is 63, 43. So therefore, we can get the one next to it by saying 180 minus 63, 43. And we get 116, 57. So this one here is 116, 57. So if I want to get to alpha using exterior angle of a triangle, I'm going to say alpha is equal to 116, 57 minus 68, 2. All right. And let's just get our calculator up. So it's 116, 57 minus 68, 2. And that's going to give me 48, 37, which is fantastic because that is what they asked you to show that alpha was. Okay, so angle of inclination, important section. You've done it over and over again, hopefully by now. And hopefully with this question, it just sort of makes it all come together. Okay, Bonga, over to you.
Okay, guys, clearly Natasha was on a roll, so we need a break. Go get some water, come back quickly to hear more about the competition. Keep watching. Hi Mindsetters, welcome back. I've got very exciting news. The competition I mentioned earlier, it's called Stop the Clock. What you need to go is go to www.mindset.co.za/learn/stop the clock. And then what you do is you enter the entry form, you choose a number from 0 to 9. Then the winner will be the person whose last number is at the end of the show. So get liking, and there's an opportunity to win Deep House Chronicles. And the last show, we're going to be giving a CD case. So ladies and gentlemen, enter the competition. You might be the winner of the Deep House Chronicles. Natasha, over to you.
All right, guys. So before the break, now this is a very, very long question. Before the break, we finished off part 5 of question 1, which was we had to find the angle alpha. And we saw that the angle alpha was 48,37 by using angles of inclination. Now, the last part of the question, they ask us to find the area of triangle DCF, which is drawn here in green. Okay, so we want the area of this triangle. Now, notice, guys, because you've worked out alpha, we should really try and use it. So there might be other ways to work out the area of triangle DCF, but we like to use the information that we've just worked out, which was angle alpha is 48,37. Okay, let's just go back and make sure that was the value. Yes, okay. Right, so we've got that angle alpha is 48,37. Now, you'll remember from trig that if we want to work out the area of triangle ABC, all right, and we've got sides A and B, it's going to be a half AB sine C. Okay, so applying that to our diagram, if we work out this length here of DC and we work out the length of CF, then I can use the area rule to say, well, the area of triangle DCF is going to be a half CD times CF sine of the included angle, which is sine of alpha, which is sine 48,37. All right, so therefore the area of triangle DCF is going to be equal to a half DC times CF, and then we're going to times that by sine of alpha. All right, what you'll notice, guys, is that we don't have the lengths of DC and CF. So all we've firstly got to do, very simply, is work out the length CD and CF using the distance formula. Okay, so let's do that first. So we want CD. Okay, so this is from the distance formula. It's going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. So if we go to the points C and D, all right, so I'm going to say minus 4 minus minus 2. So minus 4 minus minus 2, so it's going to become plus 2 squared plus minus 3 minus minus 8. Now remember, when you're timesing negative by negative, it's going to become positive, so it's going to be negative 3 plus 8 squared. So that's going to give us 2 minus 4 is 2, 2 squared is 4, plus 8 minus 3, 5, 5 squared is 25. So we're going to get the square root of 29 as the length CD. Let's do the same thing for CF. All right, so CF, we're using the coordinates of F. Remember, we worked this out right in the beginning of the question. It was 2 and 0. Okay, so we're going to say 2 minus minus 2, so it's going to become 2 plus 2 all squared plus 0, which is the y coordinate at F, minus minus 8. So we're saying 0 minus minus 8. A negative times a negative is a positive, so we get just 0 plus 8, which is 8. 2 plus 2, 4 squared is going to give me 16, plus 8 squared is 64. So 16 plus 64, what is that? My mental arithmetic's not too good. I think it's 80. Let's just double check that. 16 plus 64, 80. Okay, great. So we've got the lengths of CF. We've got the lengths of CD. Now all we do is straightforward application of the area formula. So we're just going to say a half times root 29 times root 80 sine of the included angle. All right, so the area now, and this is of triangle DCF. It's going to be a half times root 29 times root 80 sine of 48,37. Okay. Plug all of that into your calculator. So it's 0.5 times the square root of 29 times what do we have? Root 80 and sine 48,37. Okay, and that gives us 18 square units. So the area is 18 units squared. Okay. All right. So finally, guys, we are done with question 1. Okay, it's a typical exam question straight from the supplementary exam, and obviously you know that the best way to learn for exams is to do lots and lots of past paper questions, which is what we're helping you with today. So before I go on to the next question, which is undoubtedly going to be another long one, let's quickly cross and see if you have any questions for me. Bonga?
Natasha, it seems that the mindsetters are also understanding, but I'm loving what's happening on the page. A lot of them are interacting and asking each other relevant questions, not many directed to Natasha. So a quick shout out to KB, Frankie, Celine Dile, and Percy. You guys are very active on the page. Keep on liking the page, mindsetters. Natasha?
All right, guys. Okay, so then we're ready to go on to question 2, continuing with analytical geometry. Okay, let's have a look at this one. We've got that circles C1 and C2 have the same center. Now, if you look at this diagram, it looks kind of confusing because C1 and C2 are not drawn in. Okay, but what they're saying is if you were to draw these circles, they will be concentric. Remember, concentric means they both have the same center. So another way we could have said this, you know, because they just explicitly state that C1 and C2 have the same center M, we could have said that they're concentric. Okay, so remember that. All right, so we are given that C1 and C2 have the same center M. P is a point on C2. PM intersects C1 at D. So PM intersects the circle C1 at D, right? And very importantly, they say the tangent DB to C1 intersects C2 at B. But very importantly is the tangent. Now remember, tangent means that this line, the straight line, is going to simply just graze angle C1. It just touches it at one point. Okay, so that's an important bit of information. And they then give you the equation of circle C1, and they give you the equation of line PM. So before we get started, let's see if we can put some sort of shape to angle C1, which they've given us quite a lot of information about. All right, so I'm going to try and draw a circle and not freehand because I'm not very, very good at that. Let's see. Let's try and get this circle. I will get rid of it, but I just want to show you sort of what's happening. So we've got the circle, and as I say, I'm going to get rid of it. I know it's blocking all of the diagram right now, but I want to give you an idea of what's happening. So we have this circle. Okay, it looks more oval, but get the idea. And we know that the center is M. Okay, so that's sort of what the circle C1 is looking like, okay? It's got the coordinates, the center M, and we've got this tangent DB just grazing the circle at some point. So just in your heads, you sort of have an idea of how it's looking, okay? We'll draw it again later on and refer back to it. Okay, so for now, we're just going to get rid of that circle. There we go. And let's look at the first question. Okay, firstly they say work out the coordinates of center M. Now, remember, they've given you some important information here. They tell you that M is the center of C1, and they've given you the equation of the circle C1. So all we simply have to do is complete the square and write this in the form x minus a squared plus y minus b squared is equal to r squared, and that will help us to work out the coordinates of the center of the circle. All right, so we're going to take this expression and rewrite it and then work out the coordinates of the center of the circle. Alright guys, I'm going to have to quickly have a break because I think that they've left the radius out in this question, or I'm just going to have to quickly check my notes. So quickly, Bongi, can you just have a look at our Facebook page and maybe keep the guys busy for a second while I look and see?
Okay, guys, I'm loving the interaction between them. Actually, someone is asking about the coordinates of a certain calculation, and I see Njabulo helping you guys. That's what Mindsetter is about. You guys should help each other on each and every page. So Natasha is sorted now. Let's go to Natasha.
All right, guys, I see what's happened. In this question, there's just been a little printing error, okay? This is supposed to be x squared plus 2x plus y squared plus 6y plus 2. Very important. If this was not in the question, we couldn't really do it because we're not sure what the radius is going to be and what to work with. We've left out equal to naught. Okay, very, very important. Has to be put into the question. If you look at this exam paper, it was probably written there. Okay, so we've got that expression equal to naught. Okay, and we just have to complete the square to work out the center. So we've got x squared plus 2x plus y squared plus 6y plus 2 is equal to 0. So that's the equation that they've given you. Now what we've got to do to write this in the form of circle of center, we need to complete the square. Okay, and you guys should be quite familiar with this, but I know some people still get a little bit confused, so we'll go through it in detail. First step, we need to take the 2 over to the right-hand side, so it's going to become minus 2. Okay? Then we need to complete the square with the x portion and complete the square with the y portion of this expression. So we're going to get x squared plus 2x, and then we say we add a half of the b term squared, so it's going to be a half of 2, which is 1 squared. And then, very importantly, we've got to add that 1 onto the right-hand side, because remember, it's an equation. Whatever you do to one side, you have to do to the other side. Okay. Then we've got y squared plus 6y, and then we add a half of that b term, which is 6, and we square that. And we add it once again to both sides because it is an equation. So complete the square with the x part of the expression. You're going to get x plus 1 squared. So I've simply just factorized x squared plus 2x plus 1. That gives me x plus 1 squared. Factorize y squared plus 6y plus 9. That will give me y plus 3 squared is equal to, we've got minus 2 plus 1, which is minus 1. Minus 1 plus 9 is going to give me 8. Okay, so therefore, x plus 1 plus y plus 3 squared is equal to 8. I can say from there the center M is going to have coordinates minus 1, minus 3. Remember to always change the sign when you take things out of your bracket, hey? Because if x plus 1 is 0, we get x as minus 1. So the x coordinates at M is minus 1. The y coordinates at M is minus 3. And we know r squared is 8, therefore the radius would be the square root of 8. Okay. All right. Which we've already answered. We've actually answered now question 2.1.2, which says find the radius of circle C1. Well, by completing the square, remember you get it in that form, in the correct form. So this is the form, remember, that we use, x minus a squared plus y minus b squared is equal to r squared. So now that we've written it in that form, a and b gave me the center of the circle. R squared is 8, so therefore r is equal to the square root of 8, and that is the radius of circle C1. Okay. All right, guys, so as I said, this is quite a long, involved question, so let's get straight to the next one. Okay. All right, I think, yeah, let's take an ad break and come back and have a look at the next of the questions because it's very, very long, very involved. So I think you need a little break. Yeah?
Okay, mindsetters, before the quick break, because Natasha's really on a roll today, even the mindsetters are commenting that they're enjoying it very much and they're finding it easier. Before that, where you could find the notes, you go to www.mindset.co.za, then you say /learn/extra, then /winter school. Hope you get the notes, mindsetters, after the break. Mindsetters, welcome back. I hope you've had your glass of water. I've even had one to keep up with Natasha because, like I've mentioned, she's on a roll. I like what's happening on Facebook. Keep on. Let's move on to Natasha, guys.
All right, guys. So I hope I'm not rolling on without you, and I hope that you're all following me. And it's holidays, and it makes it nice, and you don't have to stress about school, homework, and that kind of thing. So hopefully you're all concentrating. And obviously, if you have any questions or if you spot a mistake or whatever the case is, let us know. Okay, so now this is part 2 of the same question, right? So far we've completed the square, we saw that the center M, and I'm just going to write it down again. We saw that the center M was -1, -3. All right, and we saw that the radius was the square root of 8. Okay, so that's the information we've got from the first part. Now they say, determine the coordinates of D, which is the point where the line PM, right, and the circle C1 intersect. Now guys, what I've done, and if you have the paper in front of you, you'll see that the circle is not drawn in, but I've put the circle in to show you what's happening on the diagram. Okay. So I've drawn this circle centered at M, it's circle C1, it intersects this line PM at point D. All right, and remember they also told us in the question that DB was a tangent to the circle. So that's just from the information they gave us in the question. So it wasn't something that I just made up, it was from the information in the question that was given to you. You can actually draw the circle yourself. Okay, all right. So we want to look for D, which is the point of contact, or the point of intersection between the circle C1 and the line PM. Remember, if we go up to the question, they also told you that the equation of line PM is x minus 2. Right, and it's on the diagram here. So we know that that equation is x minus 2. We have the equation of the circle, okay, that was also given to us. So therefore, if I want to find this point D, now remember, that's the point of intersection between the circle and the straight line. How do you find points of intersection? Just generally from graphs. You'll remember that to find a point of intersection, you have to solve the two equations simultaneously, okay. So I've already completed the square, so I'm just going to write that down again. So I've got, for circle C1, x plus 1 squared plus y plus 3 squared was equal to 8. I've got that. Now if I want to find the point D, all I have to do is simply solve this line, PM, which is y is equal to x minus 2. I've got to solve that simultaneously. So that means I'm looking at this circle C1, going to solve simultaneously with those two equations, okay, to find the point of intersection. So let's do that. Now, I've got y is equal to x minus 2. I can call the top equation, the circle equation, equation 1. I can call the equation of line PM equation 2, and I can say substitute equation 2 into equation 1. Okay, now remember from equation 2 we've got y is equal to x minus 2. So that means in this expression for the circle I can replace y with x minus 2. So now my circle equation is going to become x plus 1 squared plus x minus 2 plus 3. Do you see what I've done there? I've replaced the y with x minus 2. Okay. So we're going to get x plus 1 squared plus x plus 1 squared. Because if I simplify within that bracket, 3 minus 2 is 1. Right? So I get x plus 1 squared again. So if I've got x plus 1 squared plus x plus 1 squared, that's 2 lots of x plus 1 squareds. Hey? Or you can simply just at that step multiply out and solve. Alright, I just wanted to simplify it a bit. But that's 2x plus 1 squared. Divide through by the 2, so I get x plus 1 squared is equal to 4. Alright, we're looking for x, so we square root both sides. Guys, if you don't like this method, as I say, you can times it out from here and do it the normal quadratic way. So square root both sides, the square root of 4 is plus or minus 2. So therefore x plus 1 is equal to plus or minus 2. So we're going to have x plus 1 equaling 2 will give us x is equal to 1. Or x plus 1 is equal to minus 2, which gives you x is equal to negative 3. If you look at the drawing, however, you will see, look at where M is. Do you see? It's a point there in the third quadrant. So therefore, it can't have a positive x value. Okay, you'll see that it's a point where x is negative. It's on the left-hand side of the y-axis. So therefore, this value of x is equal to 1 is not applicable. So therefore, x must be equal to negative 3. All right, so that's the one we're looking at. Remember, this is now for the coordinates at point D. We still need to work out the y value. So all we're going to do is take that x value, substitute it either back into the equation for the circle, which is slightly more complicated, or you can put it straight into the equation of the straight line. Because remember, when two graphs intersect, all the points are exactly the same. So you can put it into either the circle or the straight line. You'll get the same answer. So we've got y is equal to x minus 2. So therefore, y would be equal to, substitute x is negative 3. And we get y is equal to negative 5. So therefore, D is the point negative 3, negative 5. Okay. And what I always say to students is look at your diagram. You know, you obviously can't talk to yourself in the exam. Sorry, I pointed at point M there when I was doing the little explanation, but I meant point D. Okay, so D was the one where you couldn't possibly have a positive x value because obviously it's in the third quadrant and your x values would be negative. All right, now what I was saying is always look at your diagram and it needs to make sense. We can see that D is a point in the third quadrant, so therefore both your x and y values, when you work them out, they should be negative. So just keep that in the back of your mind. And obviously if we then got, say for example, the y value at D was positive 5, okay, we know that that doesn't make sense because positive 5 is above the x-axis. So just look at your diagrams and sort of keep your thoughts together if you can and see that they make sense. Okay. All right, so we've got the point D. Let's see what they want of us next. Okay, they then say it is given that DB is 4 root 2. Determine MB, the radius of circle C2. All right, so they've given you DB, this distance. From there to there is 4 root 2. And they then want MB. Now remember, we've got this other big circle, C2, going around like that. Okay, so that kind of thing. So they want you to find the radius from there to the point B. Okay, so they want that distance. And what I'm going to do is I'm going to go back to the other diagram where we've got the nice circle C1 drawn and show you from that diagram how we can work out the length of MB. Okay, so they gave us that the length from D to B they told us that that is 4 root 2. We also know that MD is root 8. How do we know that? It's because it's the radius of this little circle, remember? And we've worked that out a while back. They then want us to find this distance from M to B. Okay, so you can all see that quite clearly now. And let's just mark on this diagram what we have. So we know that dB, they told us, is 4 root 2, right? We know that MD was root 8. Okay? They want us to find MB. Okay, guys. So this is going to require just a little bit of geometry, which, you know, you should know this theorem by now, which is that the line drawn from the center of the circle is perpendicular to the tangent. So the radius is perpendicular to the tangent at the point of contact. Now remember, they told us that dB was a tangent of the circle. And we know that MD is the radius of the circle C1. So therefore, where MD meets dB, the angle formed is 90 degrees. Okay, because radius perpendicular to tangent. Okay, if you didn't realize that, if you didn't know that, well, obviously you know it now, but if you didn't know that, then this question was going to be very, very difficult for you to do. But you have to know that the radius is perpendicular to the tangent at the point of contact. Okay. Why do we need that? Well, very importantly, if we've got a 90 degree in a triangle, we then get a right angle triangle, which means we can use Pythagoras. Okay, so now we can use Pythagoras to work out the length of MB, because we see that MB is obviously the hypotenuse of triangle MDB. Okay, so let's write all of that down. So we're working in triangle MDB. We know that dB was 4 root 2, and we know that MD was the square root of 8. Okay, so to find MB, we're going to say, using Pythagoras, MB squared is equal to MD squared plus dB squared. Okay, and that's Pythagoras. And the reason we can use Pythagoras is because obviously we know radius is perpendicular to tangent, which gave us that 90 degree. That's how we got to a 90 degree triangle. Okay, so MD squared is going to be root 8 squared plus dB is going to be 4 root 2 squared. So that's going to give me 8 plus 16 times 2, because if I square the 4 I get 16. You square the square root, it disappears, so we're just left with what's inside, which is the 2. 16 times 2 is 32. 32 plus 8 is 40. So MB squared is 40, so therefore if I want just MB, I need to take the square root. So the answer here would be square root 40, which you can simplify to 2 root 10, because we can say, well, 40 is the square root of 4 times 10, and then we can take the square root of 4 to give me 2 root 10. So we could have asked you to show that the length of MB was 2 root 10, which basically involves a simplification of the square root of 40. Okay, so we've got MB is equal to the square root of 40. You can leave it like that. You don't need to simplify it, okay, unless they say so. So we've got the length of MB, and that's part 3 of this question done. I hope that you're all following. I know this one is a little bit tricky because the diagram is a little bit tricky. So if you have any questions, please let us know. And on that note, I'm going to cross over and see if you have any questions.
Okay, Natasha, Theo on Facebook is asking, can you please explain the circle away from origin and how you get the equation of the circle?
All right, Bonga, we did that right in the beginning of this question. So for the circle of center, remember they gave us an expression and we had to complete the square. Okay, I can show you how we've done that, but it sounds like you need to know right from the beginning. So it might still not make sense if I show you this question. But if it is something you're struggling with, then you need to go back and revise the work that you've done. Or maybe you haven't done circle of center yet. At this stage of the year, you should have done it, but maybe you haven't, okay? And that might be why you're not understanding circle of center. But basically what we did, and I'll show you very quickly, it was question 1, the first part of question 2, where it said, show what the center of the circle is and then find the radius, and I simply took the equation they gave us, which is x squared plus 2x plus y squared plus 6y plus 2 is equal to 0, and I completed the square. Now when you had to complete the square, obviously not going into too much detail, because if I had to teach you from scratch how to find the center of circle of center, you know, how to find the coordinates of A and B, that will take us the rest of the lesson. So without going into too much of detail, what you need to do is you need to rearrange your equation. So you have your x's together and your y's together. Everything that doesn't have x and y, you move over to the right-hand side. You then complete the square with the x portion, and you complete the square with the y portion, and that will then give you this form. X plus x minus a squared plus y minus b squared is equal to r squared, which is your standard form for circle of center. So you'll get to that. Okay, so if you complete the square individually with the x portions and the y portions, you will then get to that standard form for circle of center. But as I say, the purpose of today's show is not to show you from scratch how to complete circle of center. If that's something you're struggling with, you need to go back and maybe revise a little bit, or maybe you'll get to it later on in the year. Okay, so anything else, Bonga?
No.
All right, so just that.
Yeah, just that.
Okay. So guys, we're going to move on now. So we've done, I think it's 3 parts of this question. I'm actually losing track because there's just so much to it. But let's have a look and see where we're at. All right, we're at the point where they're asking us question 2.4 to write down the equation of C2. So that's the other big circle, remember, that has the same center as circle C1, and they want it in that form. I'm going to do a rough drawing, and remember it's very rough, and my rough drawings are never ever very accurate, but we've sort of got this, okay, which barely looks like a circle. But anyway, we've got circle C1 with center M, all right, and then we've got a bigger circle C2 doing something like that, okay, and they both have the same center, M, all right. We've also just worked out MB, okay, that was the question, that was quite a long question that we just did. We saw that MB was the square root of 40. Now remember, we've worked out right in the very, very first question, 2.1, we've worked out that the center M was minus 1 minus root 3. Okay, we've already worked that out. So all I've got to do now is simply use the center of the circle, those coordinates M, and then the radius MB to write the equation of circle C2. Okay, so we know that the value of A is minus 1. We know that the value of B is minus 3. And we know that R is root 40. So you simply put those values in. So we get X minus 1 squared plus Y minus 3 squared is equal to R squared, so it's going to be root 40 squared. Okay, and we simplify that, so we'll get X plus 1 squared plus y plus 3 squared is equal to root 40 squared will just give me 40. Okay, so that one is nice, quick 2 marks, easy 2 marks. We simply put in the center M, put in the radius, and good to go. Okay, all right guys, I think we can either take an air break, but I think let's just finish off this question so it's done and dusted, and before we come back and then do another very, very long one. So let's just get this one over with, okay? And hopefully you can all hang in there for your water break. Okay, so the last part of this is the point F, root 2 root 5 and 0, inside the circle C2 and support your answer. Now, this point is not drawn, obviously. Okay, we know that it's 2 root 5 and it's somewhere. Okay, we can obviously plot it because we have the coordinates. But anyway, so they're saying, is this point F, assuming we're not plotting it, but is this point F going to be inside the circle somewhere, or is it going to be outside of the circle? So is it going to be in here somewhere, or is it going to be outside? Okay. The best way, in fact, I would think probably the only way to determine that is to look at the radius. Now remember, we've got the radius of circle C2. We know that it's the square root of 40. Now, if we want to find if F is inside or outside, that length, M to F, so from the center to F, if that length, MF, is less than the square root of 40, which is the length of the radius, if it's less than the radius, then obviously the point F is inside the circle. If, however, the distance MF is greater than 40, so it's greater than the length of your radius, then that point F is going to be outside the circle. So that's what we're going to do. That's the concept we're going to use. Okay. What that simply means is we just need to work out the distance from M to F and then decide. Okay, so let's do that. All right, so we've got F. We know that M is minus 1, 3, so therefore MF is going to be the square root of. All right, and let's just write down M just in case anyone's forgotten. M is minus 1 minus root 3, and we've got the point F there. So I'm going to say 2 root 5, using the distance formula, minus minus 1, so it's going to become plus 1 squared, plus 0 minus minus 3 is just going to be 3 squared. All right, and this is going to give me, I'm not going to simplify the 2 root 5 plus 1. Let's just leave that as is for now. Plus 9. Okay, and let's just simply put that into the calculator. So we're taking the square root of 2 root 5, say 2 root 5 plus 1, and we're going to square that entire thing, and we're going to say plus 9, and that's going to give us 6,24. All right, so MF is 6,24. Now remember, we've worked out that the radius was the square root of 40. So all we simply have to do is go back to the calculator, say, well, what is the square root of 40 in decimal terms? And we get 6,32. So therefore what we've got is we've got MF, that distance, being less than the radius. So therefore, since MF is 6,24 and the radius of the circle is 6,32, it means that F must be inside the circle. It has to be inside the circle because it is smaller than the radius of the circle. All right. Okay, guys. So hopefully you're all with me and you're all still understanding, and I think you're ready for your break now.
Yeah. Mindset is let's go for a quick break, come back, and we'll enjoy. Welcome back, Mindsetters. This is the most exciting time because we are stopping the clock very soon. And thank you for all the entries. The winner of the Stop the Clock will win the Deep House Chronicles CD sponsored by Soul Candy Music. Natasha, let's stop the clock.
All right, guys. So let's see what is the lucky number. And
wow,
it's still refreshing, so don't get too excited just yet.
Almost got too excited. Okay, ladies and gentlemen, as we wait, we'll go on to Facebook. Thank you, everyone, for posting. People are posting to each other, and I've seen Jabulo Medula answering some of the questions that the Mindsetters have. Remember, in order to like the page, you could go to www.facebook.com/learnextra. Natasha, we ready?
Well, I'm ready, but the internet isn't.
The internet isn't right.
Yeah.
It's still refreshing.
There we go.
There we go.
All right. And
let's see.
It is lucky number
0. Wow, lucky. The person who entered 0 will be one of the lucky winners. Let's Hold Thumbs will announce it later in the show. You guys are winning a Deep House Chronicle CD sponsored by Soul Candy Music. So the person who entered and is lucky enough to win, you're going to have the CD coming right to you. Thank you for your entries, ladies and gentlemen. Over to you, Natasha.
All right, guys. So if you look and you're following along in your notes, you'll see that question 3 is a question about translation and reflection. I would like you guys to let us know what answers you've got from that question 3, and I'm going to skip straight over to question 4. Okay, so we're skipping question 3, going straight through to question 4, but please, guys, send us your answers for question 3 and let us know how you did that one. All right. So question 4, we are given two triangles, KM and K prime, M prime, N prime, and they tell us that triangle KMN, all right, which is the one in green that you can see quite nicely, that's enlarged by some factor to give you this new triangle KMN. Okay, so this new triangle K prime, M prime, N prime. So we've got this new triangle in purple, as you can see. All right. First question says, determine the factor of enlargement. Now, there are different ways that you can do this. Okay, you can use any side of the triangle and compare the lengths, and you can work out the factor of enlargement. What I'm going to do is I'm going to use side K, the new K, K prime, M prime. I'm going to work out that distance, all right? And I'm going to divide that distance by the distance from the original K to M. Okay, so we're going to take the distance K prime, M prime, which is the new distance, divided by the original distance Km, which was the original triangle, and then let's see what the enlargement factor is. All right, okay. So let's do that. Now, guys, you can see that if we look at points Km, we can actually literally read the distance of the diagram, right? So if we're looking at Km, the distance from K to M, we know the x-coordinate here. Remember, we're looking at a horizontal distance. The x-coordinate there is 6. The x-coordinate at point K is -4. So therefore, the distance is going to be, and I'm just going to move this down a little bit. All right, so this is 4.1. Let's look at Km. So we had 6 minus -4, which is going to give me 10. All right, now the bigger distance, the new shape, is going to give us, let's have a look at your diagram. So we've got here at this point, we've got the x value at that point is -6, and the x value at this point, M prime, is 9. Okay, so if I want the distance from M prime to K prime, I simply say 9 minus -6. So 9 minus -6 is going to give me 15. I want the enlargement factor, so I'm going to take the new length and divide that by the original. Okay, please remember, divide the new the new divided by the original. Don't go the other way around. You'll get the wrong factor. So therefore, we're going to get 15 over 10, which is 1, 5. Okay, so our factor of enlargement, which is what they ask for, is 3 over 2 or 1, 5. All right, so 3 over 2 or 1, 5. If you wanted to, guys, you could simply, how am I getting 3 over 2? You can say, well, 5 goes into 15 3 times, and 5 goes into 10 2 times. That's how I'm getting 3 over 2. Okay, so either way. All right, part 2. They say give the general rule for the transformation. Now, when we're talking about the general rule, we mean how do you take the x coordinate and get the new x coordinate? And how do you take the y coordinate and get the new y coordinate? So what is that rule? And all we're doing here is we're saying 3 over 2, because everything is enlarged by the factor 3 over 2. So the new one is going to be 3 over 2x, 3 over 2y to get us from the original shape or from the original point to any other point. So we just times the coordinates by a factor of 3 over 2. Okay. Right, part 3. Use the answer in question 4.2 to determine the image P prime of a point P, which is 3 and 2. So we've got some points P, which is 3 and 2. So I'll just put it down here. So P is somewhere here. That's P. And they want to know, what will this new point be P prime? Okay, so wherever P prime is, what will the new coordinates be? All we've got to do, because remember we've got the factor of enlargement, we simply need to multiply each coordinate by 3 over 2. So therefore, right, and this is now 4.3. We're looking for P prime. We were given that the original coordinates of P were 3 and 2. Okay, so therefore to get to P prime, all we've got to do is times by a factor of enlargement of 3 over 2. So it's going to be 3 over 2 times 3, and then 3 over 2 times 2. Okay, and that's going to give me the point 9 over 2, or 4.5, and 3. Okay, and so those are the new coordinates of this new image, P prime. Okay. Hopefully all of you are still following, you're all with me. Remember, we are waiting to see what your answers for question 3 were, and we've just gone straight into question 4. All right, so let's get on to the next part. They say that M is a reflection of K about the line with equation x equals A. Determine the value of the constant A. All right. So let's go to the diagram. Okay, they say that M, all right, let's use green. So they say that this point M here is a reflection of this point K. And they want to know a reflection in what line. Now, when we're looking at this, we're looking at a point on a line that's going to make these 2 points equidistant, all right? So therefore, I want the distance from K to this point and then M to that line to be exactly the same, all right? And guys, that happens when X is equal to 1. So therefore, the A value is 1. All right, and we can just have a look and see, because remember, the X value at point K is -4. The distance from -4 to 1 is 5 units, so 1 minus -4, that's going to give me 5 units. And then if I went from M, which is 6, if I say 6 minus 1, I also get 5 units. So therefore, that X is equal to 1 will make sure that the line, the point M, is a reflection of point K. Okay, so X is equal to 1 is the answer to the value of the constant A. Okay, hopefully you're all still with me. It feels like I'm just talking. I want to see if I've get some feedback from you guys. Quickly, Bonga, before I carry on.
Okay, Natasha, all the mindsetters are saying is that they're enjoying the show. Some of them actually learn new equations that they never knew. So they're quite excited, and we can carry on.
All right, so Bonga, a lady of few words. Okay, guys, so we're going to have a look at what's happening to this point, to question 4.5. But remember, there's rules and lots of rules for transformations that you guys need to know. Like, for example, what happens if I take a point and reflect it 90 degrees clockwise or 90 degrees anti-clockwise and all that kind of thing. So there's lots of information that you guys, you know, you can sort of learn the rules for, and then transformation doesn't become such a mind-boggling section if it is for you. Okay. All right, let's have a look at number 4.5. Okay, we've got that triangle KMN is rotated 180 degrees about the origin to give us a new triangle, right? Give the coordinates of the point K, this new point K. All right, so we've taken the triangle KMN and we've rotated it so that, well, we've rotated 180 degrees about the origin to get to this new point K prime, which is going to eventually end up somewhere here. So we've rotated along 180 degrees to this new point. Okay, so we're going from there to there. Okay, that's your rotation. They say it's rotated 180 degrees, you want the new coordinates. What I want to show you is that when we rotate 180 degrees, we first reflect in the y-axis. Okay, so you take the point, first reflect it in the y-axis, and you then take the same point and reflect it in the x-axis. Okay, so you take the same point and then reflect it in the x-axis. You could alternatively first reflect in the x and then the y, you'll get to the same point. Okay, so let me show you on the diagram what I'm saying. So we've got this point K, which is -4, 2. Okay? We're then going to reflect that, we said, in the y-axis. So this, yeah, I'm just going to use another color there. There we go, that's your y-axis. Okay, so I'm going to reflect that point K on the y-axis. So if you're going to reflect in the y-axis, remember what happens when you reflect in the y-axis? Negative x's become positive and positive x's become negative. So therefore this point K is now going to move to that point there. Okay, so that's the first thing we do. So here at this point the coordinates would be 4 and 2. Okay, so all I've done is I've reflected in the y-axis. We're then going to take that same point and reflect it in the x-axis. Now remember, when you reflect in the x-axis, your positive y values become negative. So therefore, this K double prime is going to be 4 minus 2. Okay, so that's the point K double prime when we've rotated it through an angle of 180 degrees. All right, hopefully you're all with me. As I said, guys, some of these, you literally just have to learn the rules for them and then learn to apply them. Okay, don't spend too much of time on this section, you know, sort of pulling your hair out. If you learn the rules, it really is quite a simple section. Okay, I'm going to have a look at the next one, but in fact what I'm going to do is I want to give you the answers to question 3 because I think the next question is really, really long and we're not going to have time to finish it. Okay, yes, this is the one where we translate the triangle 3 units to the right and 1 unit up. I'm going to show you what happens here, but we're not going to have time to finish this question. Okay, so we've got this triangle KMN. It's translated 3 units to the right. So from where it is, all right, so let's just get rid of that. There we go. So this triangle, from where it is, we're going to move it 3 units right. So count with me. That's 1, 2, 3. Whoopsie. There we go. Okay. From there, we're then going to move it 1 unit upward. So it's going to move from there 1 unit up. So that's going to be your new triangle, K triple prime, N triple prime, M triple prime. That's the new triangle that you're dealing with. Okay, so using that, see if you guys can answer this question 4.6, and we'll also just check quickly if we have a second, which I don't think we do, on question 3. But guys, thank you so much for joining us today. Bonga, over to you.
Hi guys, thank you very much for joining us today. Before I mention who the winner is of the Stop the Clock, I'm going to say a quick, Mindset has a new program that is called Mindset Connections. In order to go like the page, you could go to facebook.com Mindset Connections. Ladies and gentlemen, watch today at 19:15. The winner is Mandla Giaru. Woo! Woo! Congratulations, the CD Deep House Chronicles is coming to you very soon. I hope you enjoyed, guys. We love you. Bye. Keep tuned.